we're going to cover 1.4, the distributive property. So it says the expression 3 times, and then in parentheses 4 plus 2, and 3 times 4 plus 3 times 2 are equivalent expressions because they have the same value, 18. The concept shows how the distributive property combines addition and multiplication. Multiplying a number by the sum of numbers is the same as doing each multiplication separately and then adding the products. So they kind of show it here, where if we take a times b plus c in parentheses, it's the same as taking a times b plus a times c. And then it's the same with subtraction. If I have a and then b minus c, it's the same thing as taking a times b minus a times c. So they showed a few examples there with some numbers, but we're just going to go ahead and jump right into some examples. So we have to write everything as the distributive property, even though some of you might think of different ways to solve these problems. It wants us to really focus on using that distributive property. So it says, assume that high school students spend an average of $180 on back-to-school shopping during the months of June to September. Write an expression to represent the amount of money spent in August if the amount of money spent in August is equal to the amount of money spent in July minus the amount of money spent in June. Evaluate your expression using the distributive property. So since they give us percents, to figure out the amount of money spent, you would take the total, which was 180, times the percents. Now in this case, they want us to take July minus June. Now in order to multiply by these percents, we want to turn these percents into decimals. So we got June and July that we're dealing with. So if June is 24%, as a decimal, that's 0.24. And then for July, that's 46%, which is 0.46 as a decimal. So these are the two numbers it wants us to use. So it said we have to subtract them for August. So we're going to be taking 0.46 minus 0.24. And that would get us the percent for August. And then we would multiply that by the $180. So we would have to put those in parentheses, and we have our 180. So it wanted us to write our expression with the distributive property, which there it is. Now it wants us to evaluate it. So there are two different ways you could evaluate using the distributive property. You could go ahead and subtract and multiply, or we could jump the fence using our distributive, and we'd be taking 180 times our 0.46 minus our 180 times our 0.24. So if we take 180 times 0.46, that is going to get us $82.80. Then we have minus. We would take 180 times 0.24, which is going to get us $43.20. And then we could subtract that, which gets us that August would be $39.60. Okay, so that's how you'd solve it using our distributive property, which is what it wanted us to practice. So on the next page, it wants us to go through the different steps of what the distributive property looks like for this next problem. So we'll go ahead and scroll up to it. So it says swimming. Verdell's swim team practices 5 days a week. Each day, they spend 15 minutes stretching, 45 minutes swimming laps, and 30 minutes lifting weights. Which expressions represent the number of minutes Verdell's team spends in practice each week? Select all that apply. So there are a few different ways to go about this. So if we're using the distributive property, what we'd want to do is add up all the minutes. So that was the 15, 45, and 30, and that's for one day. And you would multiply those by the 5 days. So the one that fits that is A. Now, based off our distributive property, I could then multiply that 5 to each of these and then add them. Well, the one that does that is C. So that's still equivalent, so that works. Then I could actually go through and multiply those to solve this problem. Now, they don't have that step in here. So the rest of these don't work because E, it's adding the 5 days with the minutes. So that cancels it out. B, they only multiplied the 15 minutes by 5, and they didn't take into account that the 45 and 30 minutes are also happening on those 5 days. And then D, it neglected the 30 minutes happening those 5 days. So that's why that's out. So B wants us to go ahead and solve that. So we're going to solve from part C. So if I take 5 times 15, that's 75. 5 times 45 is 225. And then 5 times 30 is going to be 150. So we can already tell automatically that B and A are out because we already have a number that's 150, which is higher than both of those. So if we take 75 plus 225, that's going to be 300 plus the 150 gets me 450. So D would be the correct answer. Now this next part, they give us a problem and they want us to rewrite it so that we'd have to use the distributive property to solve it. My suggestion in this case is to keep the first number, or at least the easier number of the two, the same. So in this first one, I would keep 5 the same. So it's using distributive property. So I need to figure out a way to rewrite 99 using addition or subtraction. So there are a few different ways you could do this. The one I went with, which is I think the easiest, is I could take 98 plus 1, and that would still get me that 99. Now it does say evaluate, so we did step 1, which is write it. Now I would take 5 times 98 plus 5 times 1. If we go and we take the 5 times 98, that's going to get us 490. And then the 5 times 1 is 5. So then I would add those two together. And if I add those two together, I'm going to end up getting that this answer is 495. Now, a good way to double check yourself would be to take 99 times 5, which is 495. So it did in fact work. So we evaluated and we rewrote it. Now, you don't only have to rewrite it as multiplication or as addition, you could also rewrite it as subtraction. So I would keep 4 the same, and then I'm going to rewrite that 1002 using subtraction. So I'm going to take 1004 minus 2. So remember, you kept these things to where they're equal or equivalent. So then we'll go ahead and we'll distribute, because that was part 1 where we rewrote it. So I'll be taking 4 times 1004 minus 2 times 4. 4 times 1004 is going to be 4016 minus 2 times 4 is going to be 8. So if we subtract those, we should get 4008 as our answer. You could double check yourself by taking 4 times 1002, which I did indeed get 4008. So that one worked as well. So those were the two parts of our answer for that one. So they want us to go ahead and check this next part. So it says estimate the value. So this one is using estimation instead of how we did it, which was breaking it apart. So if I think about 51, 51 is really close to the number 50. So I could take 7 times 50 to get an approximation. So we know our answer is going to be around 350. Now, since 51 is more than 50, that means our answer needs to be a little more than 350. Okay? So technically, you could use knowing that to help eliminate options in part B. If our answer isn't a little more than 350, it's automatically out. So that would eliminate A, D, C, and F. So now we just need to double check B and E. So they have the 7, so they kept the 7, and then they have 50 plus 1 in parentheses. Well, if I take 50 plus 1, that is 51. So B does work. So then if I look at E, they took 7 times 50, and then 7 times 1. So they distributed that 7, which we've been talking about, is equivalent. So both of these options end up working to represent the same value. So now we're going to talk about distributive property with algebraic. Right, so learn distributive property with algebraic expressions. So the coefficient is the numerical factor of a term. Like terms are terms with the same variables with corresponding variables having the same exponent. So even if we have two variables of x, if one is x to the first power and one is x squared, those are not like terms, so you can't put them together. Where if they're both x to the first or they're both x squared, then you can combine those because they are like terms. An expression is in simplest form when it is replaced by an equivalent expression having no like terms or parentheses. So the distributive property and the properties of equality can be used to show that 6x plus 2x equals 8x. So in this expression, 6x and 2x are like terms because they both have an x to the power of 1. So we have 6x plus 2x equals 6 plus 2 in parentheses x. So since they both had an x, we are able to pull that x out from each of them. And we know that if I add 6 and 2, that gets us 8. So that would be 8x. The expression 6x plus 2x and 8x are called equivalent expressions because they represent the same value for any value of the variable. So here, they want us to rewrite 4 times 5x minus 7 using that same type of process with the distributive property. So it wants us to use our distributive property, then simplify. So in order to use our distributive property, we're going to go ahead and jump the fence so that we're multiplying both things by that 4. So if I take 4 times 5x, that's 20x. And then if I take 4 times negative 7, that's negative 28. So then it wants us to simplify this. So you have to ask yourself if there are any like terms that you can combine. Looking at these two, one has an x and one does not. So they don't have any like terms. So this would be your answer. So then we can go to the next set of problems. So these are kind of asking the same idea here. So it says check, and it gives us that negative 6 to go through and distribute. So we have to multiply negative 6 to each of those terms. So we'd have negative 6 times r, which is a negative 6r. Then we'd have a negative 6 times a 3q, which is going to be a negative 18q. Then we'd have a negative 6 times that negative t, which makes a positive 6t. So here we look to see if we have any like terms, which none of these are alike because they all have different variables. So that would be the answer here. So example 4 here says rewrite, and it's using distributive property again. The only difference between this one and the other ones that we just did was they put the thing we're distributing on the other side. So we take 6 times 3y squared, which is 18y squared, 6 times y, which is 6y, and then 6 times the negative 8, which is negative 48. Then you'd see if there are any like terms. So we have a y squared, a y, and then a term that doesn't have any y. None of those are alike, so that would be our answer in simplest form. So then we have these next ones here. We're going to look for any like terms that they have. So if I look at this first one, we have 14a plus 18a. Both of these have an a to the single power, so we can combine them because they are like terms. So the way they did it was you take 14 plus 18, you pull that out, and then we have a back here, which 14 plus 18 is 32. So that becomes 32a. Now some of you will just be able to see that you can add those and you'll get 32a right away. In the next one, we have 4b squared plus 9b minus 3b. So when I look at this, these b's in the back are like terms because they both have a b to the power of 1, where that 4b squared is on its own because it's the only one with a power of 2. So we keep 4b squared the same, and we combined our like terms. Well, 9b minus 3b would leave us with a 6b. So that would be our answer for this one. So then we have this next problem up top here where they want us to go through and simplify as well. So when we go to look at this one, it says simplify the expression. If not possible, choose simplified. So we have b squared plus 13b plus 13. So we have a b squared term, a singular b term, and then a constant with no variable. Since none of those have the same variable with the same power, there's no like terms to combine. So this is simplified. So that is it for that problem. The next one here says complete the table to write an algebraic expression for 3 times the sum of 2x and 3y decreased by twice the difference of 4x and y. So we're not going to go ahead and do the table, but we will write our expression. So it says 3 times, so we're going to have 3, and we're going to be multiplying. Since it says the sum, we're multiplying that whole thing by this. So 2x plus 3y. Then it's decreased, so minus, twice, so 2. And then it's being multiplied by the difference, so subtraction. So 4x minus y. So now we need to go through and simplify this to answer the next question. Now it does want us to say what properties are being used where. So we'll go ahead and I'll rewrite the original expression. So the first thing I'd want to do is go ahead and do my distribution. So 3 times 2x is 6x. 3 times 3y is 9y. Negative 2 times 4 is negative 8x. And negative 2 times negative y is a positive 2y. So that was distribute. Now technically I distributed and I did the multiplication step since I didn't write the distribution step out by itself. Now what we can do if we look at this is we have these x's that are like terms and these y's that are like terms. So we can go ahead and rewrite it to where we have our x's near each other and our y's near each other. So if we do that, our x's, it would become 6x minus 8x plus 9y plus 2y. So I flip things around the plus sign there. So that is called the commutative property. Okay. Now we can go ahead and put parentheses, we can pull out those numbers with our variables based off how they've been doing things. So technically what they would want us to do next is 6 minus 8x plus 9 plus 2y. So this is still distributive property because we pulled out when they had things in common. From here, we can go ahead and take 6 minus 8, which is a negative 2, so negative 2x. Then we can take that 9 plus 2, which is 11. So this would be 11y. So those don't have any more like terms, so this is it completely simplified, and our reasoning would be simplify. So we have one more problem to go through here. So for this problem, they give us a whole bunch of terms and they want us to put the equivalent ones in this box. So which expressions are equivalent to 4 times the sum of 2 times x and 6? So we have 4 times, and then in parentheses it says sum of 2 times x and 6. So that's what we're adding. So it's equivalent to that first dot here on the right. So that. Now we would see what else it's equivalent to. So based off distributive property, I can multiply 4 to each of these to where I get 4 times 2x plus 4 times 6, which is the bottom right one. So we'd write that under equivalent as well. 4 times 2x is 8x, and 4 times 6 is 24, which is the bottom left one. So we'd write that under equivalent. Now if we look at these ones over here, we would see if they're equivalent. If we distribute this 8 times negative 3 is negative 24, so that would not be equivalent. If we distribute the 6, we would get a 12x, so it's not equivalent for this second one there. So these two are out. And then this last one, if we distribute that 4, we'll get a 4x, which we don't have a 4x here. So this is also not equivalent. So that is it for the 1.4 notes.